Okay, so what did we cover last time, Jad?
Operators.
Operator overloading, right? So we looked at two examples. What are the two examples we looked at operator overloading? The addition and the not equals, equality, right? Because there's assignment and there's equality. Maybe today, if we have the time, we're going to look at how to overload the assignment. We did the equality, but we can also do the assignment as well. But there's something interesting that we saw last time. We can say that an object of type money is equal to amount 1 plus 25. And we mentioned that this is possible because if there is a constructor that will take a single number like 25, then there's an automatic conversion, right? Okay. So that's an explicit call to the constructor. It will create a non-named object, anonymous object, and it will be added to amount 1. Okay. So today we're going to continue with operator overloading, and what we have today is unary operators. So those are operators that will only take one operand, not two operands. Binary operators like the addition, they take two operands, right? But today when we look at the overloading of unary operators, we're talking about operators that will take only one operand. So we say minus y, or we say y plus plus, or y minus minus. So in addition to overloading operators that are binary operators, we can also overload unary operators. Okay.
When you say plus plus, we're calling the function twice?
When you say plus plus, you're calling one function only, which is the increment function. Okay. This is an example of how to use it. We'll look at the code in a minute. So this is a unary operator. So you say amount 3 is equal to minus amount 1. This is a binary operator. We can give both operators the same name, and C++ will distinguish between the two. How would C++ distinguish between the two functions? It's the same function name. It's called operator minus. But how will C++ distinguish between the binary operator and the unary operator? Number of arguments, right? That's obvious. Okay. So in this case, we only have one parameter, and in this case, we have two parameters. So let's look at the code. Okay, so operator minus and operator minus, both of them, they have the same name, but they have different parameters. We know this from programming 1, that we can have two functions with the same name, two or more functions with the same name, given that they have different parameters, right? Okay, so now we have two functions with the same name, but they have different parameters. So this function, it takes two parameters. This is the binary function, and this is the unary function. Okay, so as you can see here on the right hand side, or the parameters, there's only one parameter only. Both of them are friend functions. Both of them, they return an object of type money. Okay, let's see how is this function being called in main, and then we'll look at the implementation of it. Main is not there, so we can go back in a minute and look at the slide the way that it's given in the slides previously. But this is the implementation now of the unary operator. It's going to create a new object. The only data member we have is all sense. So if you want to negate that object, if you want to make it negative, then the only thing that you have to do is for the all sense to multiply it by minus 1. So if it was a negative number, it will become a positive number, and if it was a positive number, it will become a negative number. There's nothing else to do. So you're just creating a new object, and you're assigning the all sense of the new object to 1 minus 1 of the parameter. And then you return that object. Okay, now if you go back to the slides, this is the way that it's going to be called in main. So this is operator minus, and you're passing it one parameter only, and this function will create a new object of type money, and it will assign the all sense to the same all sense of the amount, but it will multiply it by minus 1, and it will return it, and it will be stored inside the left hand side, which is amount 3. Okay, so it's very similar arrangement to this function. Again, if you look at the function for the binary operator, this is the function for the binary operator. It will start by creating a new object. In this case, we're also starting by creating a new object. And the all sense in this case is going to be the all sense, the difference between the two all sense of the both parameters. But in this case, it's just minus 1 times the all sense of the one parameter that we have. In both cases, we're returning the new object that we have created. And of course, as you can see in the signature of the function or the header of the function, in both cases, we're returning an object of type money. Okay? So please do interrupt me if you have questions. Yes, Munir.
So every time we use plus or minus in the main, it's calling the operator function. So what if we don't want to call the operator function and use plus or minus to add or subtract?
Yes. Okay. So your question is, if I rephrase your question, it's the following. When you use the minus over here as a binary operator, and we did not create a function which is called operator minus, would it work in the first place? The answer is no, it will not work in the first place. So it's not like you have a choice. You don't have a choice. Because this operator, the minus, it's not defined for your money object. It's defined for numbers. This is not a number, this is an object.
No, if we have an object, if the function is already defined, do we have a choice whether we can use the minus?
Give me an example of a function which is already defined.
Like, okay, the operator add, the operator plus function, it's already implemented, it's there. So every time
but it's not implemented, you implemented it in your class.
Sorry, define
it. It's you who defined it in your class. C++ did not define it for you. C++ does not know what does it mean to add two objects of type money. You don't have a choice. And your question is, what if I want to use the default behavior of minus and I don't want to overload it? You cannot do that because there is no default behavior of minus for your money object, because C++ does not know what does it mean to subtract two objects of type money. Subtract is defined for numbers. It's not defined for your object. Yes? No? So as you can see now in both cases, what's being returned is an object of type money and it's assigned to the left-hand side. Okay. Now what we can also overload is the stream extraction operator and put to operators. This is the proper names. But those are the input and output if you wish to call them that way. But this is called the string, this is called the put to operator because you're going to put something to the screen. And the other one, the input, is called the stream extraction operator. Okay, you can call them input, output, but you should also be familiar with the other names. Okay, this is an operator. In fact, you can look at this as if it's a function call now. This is the function call. This is the name of the function, and it's passing two parameters or two arguments. What are they? The output stream cout and the string hello out there, right? So this is a function, and this is one argument, and this is another argument. Now, can we override this? Yes, we can. But why do you want to override this? Because it would be nice if we can use it for the money object. So instead of calling amount1.print, we can just say cout amount1. And instead of saying amount1.input, we can say cin amount1. It's much more natural, okay? But now, before we do this, there's a couple of things that we have to understand about the behavior of cin and cout. Yes?
The minute we override anything, the plus, the minus, and these, we cannot use them as we usually use them in.
But this is the same question now again, so I have to address the question in a different way. Selma, just a minute. Let me just answer one question at a time, please. Money, amount 1, amount 2. And then somewhere in main, and let's have amount 3. In main, if you come and say, so after reading amount 1 and amount 2, if you say amount 3 is equal to amount 1 plus amount 2, this will not work. This will not work because there is no plus for the money class. Ask your question again, Jad.
Professor, I'm saying that we already defined the plus.
No, before defining it, ask your question again, the same question.
Can we use the plus
yes.
to add normal to integers?
Okay, yes, we can use the plus to add two integers, but we cannot use the plus to add two objects.
Even though it's already defined?
Unless you define it.
I'm saying that's already defined.
No, who defined it?
I define it.
خلاص, C++ did not define it for you. There is no default behavior for the plus for two objects.
So it means you will use the plus sign to add integers.
After I define it for the object, I will use it for an integer. I want to just add two normal integers as if I'm adding two numbers or multiplying or whatever.
Okay.
By default, it will accept.
So just a minute. Okay. Now this is your question, right? So, now this is the function which is the plus operator, right? What are the types of the two parameters or the arguments? Integer and an integer. So why would this function be called if this function takes two objects of type money? This is two objects of type money and this is two primitive data types of type integers. Why would C++ confuse this operator with this operator?
So we cannot. That was my question.
C++ will figure out which function to call according to the parameters or the arguments that you pass, right? So in this case, you're passing two arguments of type money. In this case, you're passing two arguments of type integer. Why would C++ confuse this with that? There's no confusion, okay? And maybe you're confused because last time we mentioned that you can replace this with 25. And we mentioned that if this is the case, C++ will just simply replace this with a call to the constructor. Fine? But under no means, C++ will do the following. It will come and say, look, I'm going to replace this with the call to the constructor, and I'm going to call this to the, replace this with a call to the constructor. This will never happen, okay? Now, Control Z, back one step. The only exception is the following. If one of the two arguments is of type money and the other one is not, C++ will try to search for a constructor that will take a number. If it finds, then this function call is successful, otherwise it's a syntax error. But at least one of the two should be of type money. At least one of the two should be of type money, okay? Did I answer the question now, Munib? Okay. So that's cout. So now instead of saying amount.output, we can do it in a natural way. This is the point. So now this will be the function call. This is the function call, and this is one argument, and this is the second argument. We agreed a number of times that whenever you pass cin or cout as arguments, or cin or cout as a return type, they have to be by reference. Okay? Otherwise, it's syntax error. It doesn't work. So it's a rule in C++. It has to be by reference whenever you have any input or output stream that is being passed or returned. Okay. Now, look at this behavior. Now, we used this behavior previously from programming 1. We say cout string followed by put2 operator followed by a string followed by put2 operator followed by a string. How many times did you write cout? Once, right? But now the actual thing, what's happening is this behavior. Look at this now. It will start by printing out I have, right? Between parentheses. Can you see them? Now believe it or not, this will return cout. Now when cout is returned, this function call will be replaced by, and here's an illustration. So cout I have, it would be as if you're starting with cout I have alone. Now cout I have, this function, the put2 operator, will actually return cout. So now we have cout followed by amount. Again now, the put2 operator will actually return cout. So now we have cout followed by in my purse. So the put2 operator, it returns something. It returns the cout, which is the output stream. It doesn't have to be cout, it can be your own file, so it's an output stream in general. Okay, so now when we override this function, which is the put2 operator, we have to retain the same behavior. We cannot change it, which means that this put2 operator has to always return the output stream. So the return type of the put2 operator has to be an output stream. And we cannot return an output stream, so it has to be an output stream by reference. Okay? We did not make up this behavior. This behavior is there in C++ already. We're just mimicking that behavior, if you wish. Again, as I mentioned last time, in operator overloading, you cannot change the behavior of the operator. So it has to be the same, exact same behavior of the operator, and you're just reflecting that in your own class. Okay. So now we understand that the put2 operator has to return cout. This is how we return cout. And the first argument, or the first parameter that we have is cout. And the second parameter that we have is whatever you want to print out. In this case, what we want to print out is the money. You can either send it as money amount, or if you want to be more efficient, you can send it as a constant reference, as we agreed last time. So instead of making a money of it, instead of making a copy of it, you're just sending the address. Right? You understand this, right? We talked about it many times. Okay. So now this is what we have. This is how it looks like. So operator, put2 operator. And what it returns cout. It takes two parameters, cout and the money, and over here just print out whatever you want. So in the simplest case, I'm just going to print out all cents. Amount1, amount dot all cents. Right? What do I return? The cout. In this case, it's called outs. Okay. Of course, it's done differently because it don't just simply print out this all cents. You have to print out the negative sign, the $sign, and then, the rest of it. So that's why there's a note over here saying that this is the same code as the previous code that we have looked at. But in the most simple case, if you wish, you can just print out all cents and you're done. But it's not done that way. But this is not the important point that we're looking at. The important point that we're looking at is the way that you declare this function and what does it return. So with the output stream and input stream, it's always by reference. It's never by copy. And anyway, C++ will not allow you to do that. It will give you a syntax error. So that's the rule. Now it's the same thing for the input operator or the stream extraction operator. So again, it's exactly the same behavior. It's the operator. It returns cn itself. So it will take two arguments or two parameters. One of them is the cn, and this is what we have to return at the end. So this is what we return at the end. And the other one is the amount by reference. Should we make this a constant reference or by reference only? Why not by constant reference? Does it make sense to make it a constant value, right? This is cn. We need to read it in. So we cannot send it as a constant reference. We need to change the values. So can we send it by copy instead by reference? So just say money amount instead of money reference amount. It's not a syntax error, no?
It's less efficient.
No. Are you sure? We're reading the value, yeah. Now if you send it by copy, if you make any modifications to it, you're making modifications to your own local copy. I will not see it in main. Now we talked about this so many times. I have a document, I give you a copy of it. If I give you a copy of it and you do modifications to it, do I see them? No, I don't. I have a document and I give you the URL of the document on the website. Like Google Documents, you can share Google Documents, right? So I'll give you the URL of the Google document and you go and you modify it online. If you modify it online, will I see the modifications? Yes, I will see modifications because now you and I are sharing the same document. If I send this by copy, not by reference, then you're making modifications to your own copy and I will not see them in main, so that's useless. So you have to send it by reference because you're modifying it. If you don't understand this, you're in trouble because this is programming 1. This is pointers programming 1. It has nothing to do with programming 2. I hope that you do understand it. Okay. So the full code now, this is what we have. So we can have operator plus, this is the addition for binary, subtraction binary, negation unary operator, equality binary. Then we have constructors, nothing new over here, so we can skip this. Right, now this is a new. This is the stream extraction, cn. and what we pass it is Cn plus the amount, and what we return is ns. This code is exactly the same code that we have looked at previously. So it will read the negation, it will read the dollar sign, it will split it between dollars and cents. We looked at this before, we're not going to look at it again. Okay. But then at the end, what does it return? It will return the Cn. Okay. And then we have Cout. This is the operator Cout. Again, this is the same code that we have looked at previously, so it uses the integer division and the modulus operator. We've looked at this. And then at the end, it returns Cout, or outs in this case. Okay. So that's it for this part of the chapter. Now, what we also have, we have arrays and classes. What this section talks about, it talks about how to include an array inside your class and how to have an array of classes. We've already done this, and we've done it in a much more complicated way, right? Because we had student had a vector of courses, and the all students had a vector of students. So, and this is much simpler because it talks about arrays. It doesn't talk about vectors or dynamic arrays. So just static arrays is very straightforward. So I'm not going to go through it because I will be insulting your intelligence. But you have to read it, okay? So I'm not saying that this is not part of the course. This is part of the course that we have covered in a much more sophisticated way. Read it. There's only one thing to mention, which you already know, but just to refresh your memory, which is this is a structure. We're looking at classes as well. Let me ask you the question outside these slides. So we have the class money that you are familiar with. Now this is the question. We can have integer array 10, right? Now we can also have money and call them amounts 10. Right. Now in this case we have an array of 10 integers, right? In this case we have an array of what? 10 objects, okay? Right. In this case, how many objects do we have? The default constructor, how many times is it called? Once. In this case, how many objects do we have? The default constructor, how many times is it called? It's called 10 times. Okay? So each of the elements inside the amounts array will be initialized using the default constructor. Okay? Some compilers, some environments, the Visual C++ environments and so forth, when you declare even integers, they will initialize all those integers to zeros. But this is not guaranteed, okay? But if you have your own class and you have a default constructor, then it's guaranteed 100% that the default constructor will be called 10 times. If you're not convinced, write this code and have a breakpoint next to it over here, and step inside it. You'll see that it will send you to the default constructor 10 times. Okay? Right. So that's what that was. 11.3, 11.4. Now the fun begins because we're going to include pointers with classes. Okay? And this is the most enjoyable topic ever. The most enjoyable topic in the history of topics. Pointers, classes, and dynamic arrays. Okay. Yes, of course. Let's start by looking at the interface of this class. And what we're going to do now, we're going to do the following. We're going to create a class that contains a character star string str. So we're going as if we're going to create our own C++ string class. We're going to create our own C++ string class. in the internal representation of it, there will be a private data member that looks like this, a pointer to a character. Okay. Now later on in the constructor, we have to do something like this: str is equal to new char, and then we read the number of characters from the user. So we're using dynamic memory allocation. Okay. Right. Now, just to refresh your memory, in C strings, not C++ strings, this type of strings is called C strings when you have an array of characters. If you have something like C, if this is your string, just to refresh your memory, in C strings, they always end up with a \0. So it's actually an array of characters which ends by a \0. We know this from programming 1. Okay, so now what we're going to do, we're going to create our own C++ string class. Okay, and inside it, we're going to have a data member, which is the string pointer to a character. Most likely, there will also be a size. We'll look at the header in a minute. Okay, we're going to do this in the constructor after we ask the user for the size. And eventually, somewhere inside the code, we also have to delete the string, right? So delete, we're deleting an array, which is called the str. It's an array of what? It's an array of characters, right? Okay. So somewhere inside our code, we're going to do this. Somewhere inside our code, we're going to delete. And we're going to introduce a new function. We know that we do this inside the constructor, right? And we're going to introduce a new function, which is called the destructor. So you can construct and you can destruct. So there's a constructor and there's a destructor. Okay, so today we're going to look at the destructor and understand how it works as well. Right. So let's start with the header. This is the header. So we're going to create our own string class. It's going to be called myString or string variable. Call it whatever you want. But there's a default constructor. Let's look at the private data members first. All of those will be implemented eventually. There you go. So what we have is the value, which is an address of a character, which is a dynamic array. We'll create a dynamic array out of it. Call it string or call it value, whatever you want. We also need to have the maximum length of it. That's the only two members that we have, data members. Now let's look at the functions that we have. The functions that we have is, what's this? This is a constructor, and it takes one argument only, which is the size, right? Is this the default constructor? No, it's not. Default constructor does not take any parameter. Okay. And then what we have as well is the what's this? Default constructor. This is a third constructor. And what do you think it does? This is an array of characters, right? It's a constant, so we cannot modify it. But this is an array. It seems as if we're going to take this array of characters and copy it to our own string. What's the name of our string? Value. What's the name of our string? Value, right? Can you see it? The name of our string is called value. So it seems that in this constructor, we're going to take a C string, which is called A, and we need to copy it to value. Right. This is a new constructor that we did not see before. It's called a copy constructor. And we're going to look at the details of this. The copy constructor, what it does is the following. It's a constructor, but the parameter it takes is of the same type. So you're copying from one object to the other, and both of them are of the same class type. So the class type over here is called the string variable, and this is a constructor that takes a parameter of a string variable type. So you're copying from one object to the other. You're constructing one object using the other. We're going to look at the details of this, but just to make sure that you're happy with it, in main, this is how it looks like. So it's called string var str1, and then let's say that you have initialized this with AUS. And then we have another string var, which is called str2, And what we are going to pass this is str1. And this is what we are focusing on. In this case, we're calling the constructor and we're passing it a C string, a sequence of characters that end with a \0. In this case, we're calling the constructor, and what are we passing it? Another object of the same type. We did not see this before. This is the first time that we see it. We're constructing an object from another object. If you're constructing an object from another object, it's called a copy constructor. But why is it a copy constructor? Because obviously we need to copy everything inside string 1 and save it inside. So this is a copy constructor. This is not a copy constructor. This is one of the constructors that we have. Okay. So when you pass that AUS, this is the constructor that is going to be called, because AUS is an array of characters. But when you pass the string 1, this is the constructor that will be called, because string 1 is of type string variable. Okay? But of course, we're going to look at the implementation of this later on. This is the destructor. We did not see destructors before. Now we know that this is the default constructor. We can also have a destructor. Destructor has the same name as the class name, but it starts with this symbol. What is this symbol called? What is it called? Does it have a name? Do they call it tilde or something? Tilde? Yeah? Say again, sir? Okay, so it starts with the not sure sign. I think it's called tilde. So this says that this is the destructor. We're going to look at the rules for the destructor later on. Destructors, you can only have one destructor. So there's nothing called default constructor, destructor, and non-default destructor. There's only one destructor. It has to have the same name as the class name and start with this delta sign.
Taking no parameters.
No parameters. Yes. Say again. Tilde. Okay.
How do you get that tilde on the keyboard?
You search for it. You press all the keyboard buttons until you find it. Okay. But now this destructor is going to be called. When do you think this function will be called? It's a function that will be called automatically, of course. But when do you think it's going to be called? At the end. At the end of what? At the end of main. So let's say that this is where main started, so this is void main. And then we have plenty of code, very complicated stuff. Now we agreed in programming 1 that whenever you declare a variable, the variable lives between the two curly brackets. Do you remember that? Whether it's a function or main or whatever it is, any variable that you declare lives only between the two curly brackets. Okay? Now if you have something like this, now again I'm just refreshing your memory from programming 1, for integer I is equal to 0, and then I is less than whatever, and then what's the scope of the I variable? In programming 1 we mentioned that there's a local scope, there's a global scope, and there is a block scope. What's the scope of the I variable? Block scope, okay? I lives only between those two curly brackets. If you come at this point and say cout I, what will happen? It's an error, right? Because the variable lives only between those two curly brackets. Now, if you look at string 1 was declared inside those two curly brackets. So once the execution of the program is out of this ending curly bracket, string 1 is no longer declared. It goes out of scope. So once we are done with main and the execution goes beyond this curly bracket, they say that string 1 goes out of scope. Once a variable or an object goes out of scope, the destructor is called automatically. Is it like? No, deleting has a different concept. Deleting has a different concept. The destructor itself will actually delete. Okay. So now, if you use the new keyword inside the constructor, you have to use the delete keyword inside the destructor. Okay, and the destructor is automatically called.
So what if we add a global name, like outside the local?
If it's a global variable, it will not go out of scope. And if it does not go out of scope, then the default constructor is not called. Okay? But there are other cases that the default constructor will be called in, as we're going to see as we move on. So I'll not confuse you with that now. Yes, John?
The destructor will only be called after the constructor is being called. If the constructor is not being called, the destructor itself won't be called.
No, we can have a destructor without a constructor. It's fine. Yeah. Although it's uncommon and unheard of. Typically, you'll have constructors and destructors. You'll only have destructors if you're using pointers. You have to. So can we have a destructor if we don't have pointers? You can, but I cannot think of a useful scenario where you need a constructor without pointers. Because the use of destructors in this chapter is going to be to deallocate the memory that you have allocated in the constructor. Okay? But what's this function? Integer length. Obviously, it's returning the length. The length of what? The string that we have, the array of characters. Why do we have const at the end? This function cannot change any of the data members that we have. What are the two data members that we have? Value and size, or max size. So this function is saying, I do not have the authorization to modify the value of the variable which is called value, and the other variable which is called the maximum size. We looked at this last time. But then we have the input line. This will read one line. This is, and we're overriding the output operator, and it returns the output operator itself. This is not new. And then we have value and the maximum length. Okay, so what we need to look at in this chapter is the copy constructor, the destructor, and we're going to also override the assignment operator. Not the equality, we're done with the equality, but we're going to override the assignment operator. Okay. There are lots of details that we have to understand, and all of them are very enjoyable if you understand them. So there's the copy constructor, we'll discuss this later, and there's the destructor. Okay. So let's see what do we have in this example. When we clicked on this, it sent us to a many example. It should be the string variable. Anyway, so now this is talking about stuff that we are familiar with previously. So we know that the strings, it ends with a \0 and so forth. So I'm not sure there's lots of information over here, but let's skim through it to make sure that you refresh your memory. Okay, so let's see what we have now. This is one of the constructors that we have. It's a non-default constructor. It takes a variable of type size. And what we're going to do is the following. We're going to say that our own variable, which is called the maximum length is equal to size. Okay? Or you can use the, what did we call this? We called it the initialization section, right, of the constructor. This is only allowed in constructors. So this is as if you're saying maximum length is equal to size. Guys, you're looking at it as if it's the first time you see it. You have seen this like... Sorry. So this is the initialization section of the constructor. And now what we need to do inside the constructor, this is the memory allocation. So now we say that the value is equal to new character, which is the maximum length. Why did we add 1 to it? For the \0 at the end. So this is the total number of characters that we have, and we add 1 for it for the \0 at the end. And then we initialize it by saying that the first character is equal to \0, which says that this is an empty string. So if you want to initialize an empty string in C language, you just simply set the first character to \0. So it's a string that contains no characters. Okay. Now the second function that we have is the default constructor, and the default constructor, they're going to initialize the maximum length by default to 100. So if you don't choose a maximum length, the maximum length is by default 100. Okay. So now value is equal to new character, 100 characters, and again we're initializing it to an empty string, so the first character is equal to \0. Okay. Now, forget about the copy constructor, we'll come to it in a minute. This constructor, when did we call this constructor? If you recall, the example was this. If you say string 1 AUS, so what you're passing it, this AUS now, this will be stored inside an array which is called A. So array A now, which is an array of characters, it contains AUS. The corresponding function call is this. So this is array A, and this contains AUS. It's an array of characters. Okay. Now we're going to create our string based on the variable that we have passed, which is AUS. So now the first thing that we have to do is the maximum length. We're going to set it to the same maximum length as AUS. How do we get the length of AUS? We call the function which is called strlen. Now this is a C string function, guys. So we remember strlen. You remember str copy, str concatenate, str what else? Str copy, str cat, str length. Those are the most common ones. Okay. And then we create our string according to the length of what we have passed, which is AUS in our example. And then what do we do? What's happening over here? What are we copying? We're copying whatever is stored inside A, in our example it's AUS, to value. What's value? Value is the private data member that we have inside this class. Okay? So what we did the following. We used the function strcopy, because this is a C string, and we're copying to value whatever we have inside A. But what do we have inside A? What we have inside A is this C string AUS. Can we just instead say value is equal to A? It's a C string, it's not a C++ string. This would work in a C++ string, because in C++ strings, this function is defined for the class type string, operator overloading. But there's no operator overloading for the C string. But what will happen if you are stubborn enough and you said, no, I'm going to do it this way, I'm going to say that value is equal to A, what will happen?
You have to implement it.
But provided that we did not implement it, Ali is saying for this to work, we have to provide our own implementation of the operator equals to, correct? Let's assume that we did not provide an implementation for the operator of equal to. What will happen in this case? What is being copied to value? This is the question. The address. The address of what? Of A. Thank you. So now in this case, we're not copying AUS to value. We're just copying the address of AUS to value, because we agreed previously that the name of the array has the address of the first element inside the array. We agreed previously that the name of the array has the address of the first element inside the array. We agreed previously that the name of the array has the address of the first element inside the array. So now we say value is equal to A. We're copying the address to an address. Value, is it an address? It is an address, because this is how we declare the value. Short star. It is an address. We did not copy AUS. We copied the address of AUS. And this is not a good behavior, because if we copy the address of AUS, then what we're going to end up with is the following. Value has the address of AUS, and A also has the address of AUS, which means that if I delete A, what will happen to value? value will be pointing to a non-existing content, because now value and A, both of them are referring to the same content, which is AUS. If you delete one of them, the other one will be pointing to garbage. AUS and A, both of them, they have the address of the same content, AUS. If you come and say delete A, then this will be deleted. Okay, this is value. Now value, what is it pointing to? It's pointing to garbage. It's pointing to deleted content. So we're not interested in copying the address. We're actually interested in copying the content, which is AUS. So this is why at this point we use the function strcopy, because strcopy will actually copy the A, and then the U, and then the S, and then the \0. Yes?
So before deleting A, can value access AUS?
Before deleting it, yes. But once it's deleted through A or through value, then the other variable will not have access to the deleted content. But before deleting it, yes, of course.
Sir, if the printer doesn't work copy, you can just use the forward?
Yes. So your question is, instead of using the string copy, can we do it manually and have a for loop and copy A and then U and then S and then add the \0 at the end? Yes, you can, of course. Okay. But so I think we're going to stop here. So next time we're going to look at the default constructor and the rest of it. I'll take your questions if you have.